Here's a short video on the difference between subset and proper subset. A is a subset of B if every element in A is also contained in B. And this allows for A to actually be the same as B, for A to be equal to B. So every element of A is contained in B. With a proper subset, A is a proper subset of B, means that every element of A is also in B, also appears in B, but they cannot be equal, right? Notice the relationship, the similarity to, like less than or equal to, right? Which would allow a number to be less than another number or equal to that number. So in this case, this set would be contained in a smaller set of B or could actually be equal to B. Here, A has to be smaller than B. It cannot be the same as B, okay? So in terms of Venn diagrams, here is set B. A can be contained in or they are the same set. Whereas with proper subset, there is only one possibility, that A is contained inside of B. All the elements in A are also in B, but cannot be equal, right? So subset says A can be contained in a smaller version of B, or they can be actually equal to the same. So let's give some examples here. So let's say A is the set WAFLES. And B is the set WAFLEST. A is both a subset because all of the elements in A are also in B, but they aren't equal. B has that extra letter, okay, but that's okay. And A is a proper subset of B because everything in A is also in B. But they are not equal, right? Because again, they have that one letter difference. Okay. Let's list, let's come up with another set here. So I've got C is equal to, let's just do 1, 2, and 3. So it has 3 elements. And I would like to know, list all the subsets of C. Okay. So that means all of the sets that have something that is in C but is contained in C, right? So for example, just the set 1 is a subset of C, right? That element 1 is contained in there, so this set is a subset of, right? 1 is a subset of 1, 2, 3. Similarly, so is 2, so is the set that has just a 3. So those are also subsets of 1, 2, and 3. Similarly, all the 2-digit, right? So 1, 2, 1, 3, and 2, 3 are also subsets of 1, 2, 3. Because 1 and 2 are contained in 1, 2, 3. 1 and 3 are contained in 1, 2, 3. 2, 3 is contained in 1, 2, 3. There's one more set that is also a subset, and that is the set itself. Right? The condition for 1, 2, 3 to be a subset of 1, 2, 3 is that every element in C is also in B, and it allows for them being equal, the exact same set. Now, the question is, how is this any different? Oh, in the empty set, there's one more set, sorry. The empty set, which is a subset of every set. I knew there should be 8 subsets, so I was like, wait a minute, we're missing one. Yeah, the empty set is a subset of every set. Okay. Now, in terms of the proper subsets, okay, all of the subsets listed here, 1, 2, and 3, as well as all the ones with 2 digits, and the empty set are all proper subsets. Notice which one I didn't list. 1, 2, 3. 1, 2, 3 is not a proper subset of 1, 2, 3. Because proper subset means it has to be contained in but not equal to, right? It's missing the line under. So 1 is a proper subset of 1, 2, 3. 2 is a proper subset of 1, 2, 3. 3 is a proper subset. 1, 2 is a proper subset. 1, 3 is a proper subset. 2, 3 is a proper subset, as is the empty set. So the empty set is a subset of every set and a proper subset of every set. The only set that was not a proper subset was the set itself, 1, 2, 3.